Hey everybody, let's give this problem a try. So we have a frame with 2 pin supports and then a load over here. Okay, so what do? Break it apart. So there's this part over here, and then this one over here, and then this one over here. Okay, so then let's go one at a time. There's E, D, B, D is over here, C is over here, there's a 6 kilonewton load, and then C is over here, B, A. Okay, so there are forces acting at 3 points here, 3 points here, 3 points here. And so now let me pick coordinates, and then I'll just decompose at E, so like this. I'll decompose the reaction at E into X and Y components. And then at point D, I'll decompose that into X and Y components. And then point B, same story, X and Y components. Okay, so point B is also here. So since these are the same pin, I'll draw these equal and opposite. Right, Newton's third law. Okay, and then point D here is also here. So I'll draw those equal and opposite. And then what else do we have? Oh, point C. Okay, so that's a slider. So there is no reaction in this direction, only in this vertical direction, normal to that slot. So I'll just draw it whichever way, C. And then over here has to be equal and opposite. C. And what else am I missing? Over here, the pin at A. Okay. All right. So let me maybe make a little bit more space. Just move this over. Okay. All right, so let's go one at a time. So for this one, in the X direction, EX, DX, BX. In the Y direction, EY, DY, BY. Some torque about somewhere clever. Let's hold off on that for a minute. Let's go here. So in the X direction, we got AX minus BX. That's it. In the Y direction, AY minus BY plus C. Some torque. Let's hold off for a minute there. Let's go to our last piece here. Some forces in X. We got negative dx. Is that it? Okay. And then some forces in Y, negative dy minus C minus 6 kilonewtons. Okay, so now let's be clever. Okay, we can solve for dx at 0, so we got that. That's done. So let's sum about somewhere where we can reduce the number of unknowns. Let's sum torque about point D. Okay, so there's torque by C in the negative direction. And how far is that? Okay, so this is 1 meter, 1 meter. Okay, so this here to here is 1 meter. So here to here is 3 meters. C, and then here to here, oh no, here to here is 4 meters. 6 kilonewtons. Okay, so if we take a look at what we have here, so we got dx, that's done. And then, look, there's only one unknown in this equation, C, so solve for C, done. Substitute it here, and then solve for dy. Okay, good. So we know all 3 of these. And then that means we know C over here. Okay, and then We also know dx and dy, which is here. Okay, so how does that help us? We still have 4 unknowns here, but at best we have 3 equations. So that's not good. Okay, we have 4 unknowns here, and at best 3 equations. So we're kind of stuck. Not really. We have one more trick up our sleeve. We can draw the free body diagram of the entire frame. So let's do that. Okay, so for the entire frame, so it looks like, let's see. Kind of like this. Okay, so then there's a pin at E, a pin at A, and then the 6 kilonewton load over here. Okay, so before we even get started, I already see 4 unknowns, and at best we're only going to be able to write 3 equations, but let's see if those 3 equations help. Okay, so in the x direction, ax plus ex. Is that it? Okay, that's it. Y direction, ay plus ey minus 6 kilonewtons. All right, let's sum torque about somewhere clever. How about point A? Okay, so it's sum torque about point A. There's torque from this, which is 5 meters, negative direction. Okay, and then there's torque from Ex, also in the negative direction. That's 2 meters. There's no torque from Ey about point A. There's no torque from Ax nor Ay about point A. Okay, so that means we can solve for Ex right here. So that's good. Substitute it here and then solve for Ax. So we got that. But we wouldn't be able to solve for the other 2 unknowns. So that definitely helped. Now we have Ax and Ex. So we know Ax right here, that's known. And we know Ex right here, that's known. Okay, so let me circle that. We know Ax over here. We know Ex over here. That's good news. Right, because look, we can solve that for Bx. Solve that for Bx. Now we know this. Okay, now let's go over here. See this right here? We know Ax already, so we can solve. Oh, we already did that, right? We got Bx. Okay, so that wasn't super useful. Okay, but the good news is we have, let's see, we have 2 unknowns left over here, and we still have 2 more equations we can write. So let's sum torque about, let's be clever about it, either here or here. So whichever one. And then same story. If you look at this one, let's be clever. Let's sum torque about either here or here. Why don't I just do that since I'm here already? Okay, let's sum torque about point A. Okay, so sum torque about point A would be, how far is this? 2 meters. Okay, so negative 2 meters, by, and then from here to here is how far? 5 meters. Plus 5 meters, c equals 0. Okay, now let's take a look at it. We already know c, right? So then look, solve this for by. Now we know by. Take that value, plug it in right here, and now you can solve for ay. Okay, so now this one, we know everything. And then see, we already know by, so look right here. We know by, which is right here. So then, with this equation, solve for ey. And actually, we don't even need to write this equation. We're done. We solved for every reaction in the entire structure. Okay, so remember the strategy. Break it apart. Usually, like, you're good, you can solve it. But sometimes we needed to use the extra trick up our sleeve, which is, right, draw the free body diagram of the entire structure. Okay, so keep on practicing. I'll see you on the next video.